Jai Gurudev and good morning student. Today we start one of the most important topic of this unit. This is valence bond theory. In short it is VBT. According to this theory, the metal atom under the influence of ligand can use its n-1 into d, ns or np, n-1 into d, ns, np or ns, np, nd orbital for hybridization to yield a set of equivalent orbitals of definite geometry such as octahedral, tetrahedral, etc. Before going to the main part of that one, let us understand the point first. This is your nucleus of the atom. This is 1s. Here we have 2s, 2p. In this one we have 3s, 3p, 3d, 4s, 4p, 4d, 4f. Now sometimes what happens, for hybridization takes place between these orbitals, and sometimes the hybridization takes place between these orbitals, 4s, 4p and 4d. So that is what we have written also. This is 3d, 4s, 4p. Now if you put the value of n equal to 4, then this become 4 minus 1, means n minus 1 into d. If I consider n equal to 4, this one become n minus 1 into d, this become ns and this one np. So these things involved in hybridization, and if this is involved in hybridization, this is called your inner orbital complex. And sometime this one 4s, 4p, 4d involved in hybridization. This one is outer orbital complex. Inner means if we use the inner d orbital, that one become inner orbital complex. Now that is what is written in the theory part of this one. They can use either n-1 into d, ns or np orbital, or ns, np, nd orbitals for hybridization to yield a set of equivalent orbitals. Now if the coordination number become 4, the hybridization may sp3 1 plus 3 4, the geometry will be your tetrahedral. The coordination number 4, that one become dsp2 also. In that case, that is called square planar. Sometime your coordination number become 5. In that case, sp3d hybridization, it is trigonal bipyramidal. Sometimes it become 6 sp3d2. So this one become octahedral, sometimes 6, that become d2 sp3. So this one also become octahedral. Now we'll read about the treatment of the ligand and all these things in the next page. In this, the question is, Predict the defined features of the following entities: CONH3 6 times tripositive, COF6 tribe negative, NiCl2 dinegative, NiCN4 dinegative, NiCO4 0. Now student, one point that I want to tell you, that these ligands, you remember, CO, Cn, En, NH3, another one is NO2 negative. These ligands are called your strong ligand. Now these ligands imposes pairing. If these ligands are there, then pairing of electron take place. Pairing of electron, I want to mean that if you want to understand the pairing of electron, if the in a orbital electrons are 1, 2, 3, 4, 5, 6, pairing means after pairing they all of them get paired. So there is 2, there is 2, there is 2. 6 electrons are distributed like that. Now we are taking the first two examples. One is your CO NH3 6 times tripositive. Another one is COF6 3 negative. And rest examples you have to solve if you want. So in this case, we know the CO electronic configuration is this one. (27), but it is 3 positive. So there is 2 electron goes out from this one, 1 electron goes out from this one. Then we have to write 4p0, 4d0. What we can write for this one? So 4d. Boxes are there. Now here we have 1 electron, 2 electron, 3 electron, 4 electron, 5 electron, 6 electron. Now ligand is what? NH3. You have to write under the influence of NH3. In the influence of NH3, these electrons get paired up. So how many NH3 we have? 6 NH3. So NH3 dot dot, 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 NH3. This lone pair is donate into those orbitals. So 1, 2, 3, 4, 5, 6. How many d orbitals are used? These are d orbitals. This is 3d. This is 4s. This is 4p. So 2 d orbitals are used. So it is d2. 1 s orbital used. It is s1. 3 p orbitals are used. sp3. So in that case, you have to write hybridization is d2 sp3. Second comment, shape is your octahedral. And third one is it is an inner orbital complex. Inner orbital complex means it is inner d orbital. Now you see that the spin decreasing here. It is plus up, plus up, plus up, plus up, 2 spin, but here is plus up, minus up, plus up, minus up, plus up, all the spins will get cancelled. So if to write, this one is a low spin complex. So we can use hybridization shape, this one, next one is, it is a diamagnetic, because all the spins are paired up diamagnetic. Another one, you have to find the mu value, mu equal to under root n into n plus 2. So number of unpaired electron is 0. 0 plus 2, that becomes 0 Bohr magnet. Now similar case if I consider for this one, so up to this will be same. Up to this will be same. You have to write under the influence of fluorine, because fluorine is a weak ligand, so there is no pairing takes place. One, two, three, four, five, 6. This is S. This is P. This is D. Now NH3 will take these orbitals for hybridization. 1, 2, 3, 4, 5, 6. So this is sp3d2 hybridization. So here you have to write hybridization is sp3d2. It is octahedral. Now here the spin is maximum. So it is high spin complex. Then it is paramagnetic. Outer orbital complex. Then last one, mu value is 4 into 4 plus 2. So 2 to the power 24 Bohr magnet. So up to this, student. Thank you.